and we get right here into the write process memory. It's gonna say inject into Internet Explorer, which is the handler, in the address 40.00.00, which is the one just allocated. Is gonna write this buffer. If we right click and click on process following dump, we can see that it is a whole binary to be injected. And actually, just a heads up for you guys, if we just go down and down and down, this guy might actually be exactly the same binary, but I mean not the same binary, but little bit modified. But it is also a Delphi binary. You can see here that this program must be run under Windows 32. That's a sign of a Delphi binary that is gonna be injected into Internet Explorer, and the size to write is 3000 hexadecimal. Is the whole binary is gonna be written there. So if we click on F8, we can see that the EAX returns 1, which means it was successfully injected. So if we go back to our process again, right click, properties, go to the memory, and we click on read write, you can see that now it has the whole binary injected. Okay. After that, there is one step more to be done by the binary. Another write process memory. And this is very important, guys. So since the malware is injecting a new binary into Internet Explorer, in other words, is replacing, well, it's not replacing, it's actually injecting into a new memory space into Internet Explorer, it needs to align the execution code with its own base address. If you remember, the base address of Internet Explorer was not 40.00.00. You remember it was 01.01.0.0.0. Okay. What is gonna do the malware right here is gonna go to PEB. You can see here, if you remember, if you write it down, PEB is the address where it's gonna write this specific buffer. If we right click on that buffer, we can see that it is 40.00.00. In other words, it's gonna go to the PEB plus 8, which is this address where the base address of that process is located, and it's gonna override it with the new base address of the process, which is starting at 40.00.00. That way, when the malware starts executing, it's gonna find the proper addresses in memory. Okay, so we click on F8, it says 1, which means good to go. Then it goes to this very important step, guys. So everything is ready to start executing. Internet Explorer is infected, and now the almost last step is set threat context. Basically, the most important thing here in set threat context is what is the address to be executed first into the remote process as soon as resume thread is executed. Resume thread is gonna release the process from suspended mode into running mode, and it's gonna jump into the entry point of that specific process. Set thread context is gonna put it. So how do we know what is the address to be executed? It's pretty easy, guys. You just grab the context address, which is this, and if you print the 01DE0000, which is the context, plus 0xb0, that specific offset holds EAX value, and EAX value holds the entry point of the process to be executed. If we click enter, we can see that that value is 49F92C. Let's write it down. The entry point of IE Explorer is gonna be 49 F9 to C. In other words, as soon as Internet Explorer it resume execution, it's gonna start executing that specific address. Okay, guys. So why we need this specific address? Okay, so the reason is this. I just click on F8, and right before resuming thread, guys, if you remember, what we are trying to do is we are trying to intercept as soon as the malware start executing malicious code into the injected process. In the previous class, we saw that via create remote thread, we can just go open Immunity Debugger, another session, attach to that specific process, put a breakpoint, and wait for the malware to jump into it. In this case, guys, the process is suspended, as you remember, right? That means that if we go and open Immunity Debugger, second session, click on attach, trying to find the process injected, you can see that it's not there because it is suspended. So we cannot attach to it. So how we can be able to intercept the injection and before start executing malicious code into Internet Explorer, be able to debug it? There is a technique. I mean, there are multiple techniques, guys, but one pretty cool technique is what it is called the infinite loop. So what we're gonna do is we're gonna go to Internet Explorer into the specific address of entry point that we just grabbed. We're gonna put an infinite loop there so that as soon as Internet Explorer starts executing, it's gonna just stay in the same place. Then, since it is running in memory, we attach it with Immunity Debugger, go to that infinite loop, and patch it back to with the original bytes and resume execution. Okay, guys? So, hope you understand it. So, as I said, the first step is to put an infinite loop. And let me explain you what I mean by infinite loop. Let me just go down here into Immunity Debugger, and I'm just gonna put here an instruction. In order to put an instruction, I just click on following in dump selection, and here I'm gonna put my infinite loop. The infinite loop is a jump, which is EB opcode. It is a jump, and FE means jump -1. In other words, jump to the previous byte, which is jump to itself. If we click OK, you can see right here that it just set a jump into, it is, first of all, it is in the instruction 40DA4A, right? And then in that instruction is gonna say jump to 44DA4A. It is exactly the same offset. It is just jumping and jumping into the same location. This is what I mean by infinite loop. So what we're gonna do now in Internet Explorer is we're gonna, and just before resuming thread, we know that the entry point is 49 F9 to C. So thanks to Process Explorer, sorry, to Process Hacker, we can just go to this guy, properties, then go to memory, go to the 40,000 that was allocated with the malicious binary. With the binary, we just go to the RBA, which is F9, sorry, 9F, not 90, sorry, 9F92C. Okay, so we go 9F, around here, a little bit down. Okay, 9F, 9-2, right here, 9F F92C, which is right here. We just save that specific value, which is, because we're gonna replace it with the infinity loop, which is 55.8b. Okay, and then here, guys, which is gonna be exactly the address to be executed as soon as the process is resumed, we're gonna put EBFE. After that, make sure to click on write, even right click it multiple times, and then just close it, and we just patch it Internet Explorer in memory. Okay, so now let's allow resume thread to execute. If we click F8, if we go to Process Explorer, we can see that now it's not in suspended mode. And here, check the CPU, guys. Internet Explorer is consuming a lot of CPU, and the reason is because it is just looping. This is like a good sign that our code works properly. Okay, so then now that since it is running, we can go to Immunity Debugger and try to attach it, since we know that that specific process it is running. So we go click on attach, and we can see that now Internet Explorer is running. We click on attach. It says that bad or unknown because it was infected. It's a good clue also. And here, guys, we just break into it. Now, since the debugger break into a specific place, we just click on Ctrl G and we go to 49 F92C, which is the entry point, and you can see that here is our EBFE loop, infinity loop. We just right click, let's just re-establish the original bytes section, and here we are gonna put we just click on keep size so that we uncheck this mark so that it can allow us to write multiple bytes. So in this case it's gonna be 55.8b, if you remember, 55.8b. We click OK, and the final step is